So 23 asks you to prove that triangle AYX is going to be congruent to triangle CZX. And we are given that AB is congruent to CB. So I'm going to go ahead and mark over here. We know that AB is congruent to CB. So those two sides are equal in length. We also know that XY is congruent to XZ. So we know that bit of information. You also know that angle AXY is congruent to CXZ, which is right there. And we want to prove the two triangles congruent. To prove triangle congruency, what are the four that we have? Side, side, side. Does it look like that's going to be an option? Side, side, side? Probably not. Another one is side angle side. To do that, I would probably want to know something about AX and CX, probably. Okay, so I don't know about that one. What's another one? Angle, angle, angle side. That looks like that could be a good possibility. The last one is hypotenuse leg, and I don't have a right angle or anything stating or leading to right angles. So that's probably not what I want to use. So as I look at this and I go through trying to set it up, or let's change the color. Okay, so I have the given information marked. All right, what do you know is also true in that figure? Angle A is congruent to angle C. And why is that? Very well stated. So I know that angle A is congruent to angle C. And you could say base angles of an isosceles triangle are congruent, or as Isaiah said, angles opposite congruent sides are congruent. So I know that those two angles will be congruent to each other. Now we don't say angle, angle side. It's angle, angle, angle side. So I'm going to number two angles here. I'm going to call this a 2 and this a 3. So let's label them as 3 and 4. Just because. Okay, so I'm going to number them as angle 3 and angle 4. It's just so I don't have to use the 3-letter angle numbering or lettering naming system. So as I look at this, angle, or the third statement I can make is that angle 3 is going to be congruent to angle 4. And how do we know that? If two angles of one triangle are congruent to two angles of another triangle, then the third angles are equal, or they are congruent. So I tried to shorthand that. If two angles of two triangles are congruent, then the third angles have to be congruent to each other. And it's just angle addition, because if these two angles right here if they happen to be 30 and 60, what would angle 3 be? 90, because some of the angles have to be 180. So you also have 30 and 60 over here. So what does angle 4 have to be? 90 degrees. So those two angles have to be equal to each other. And if they were 50 and 30, 3 would be 100. But the same thing occurs in the other triangle. So 4 is also 100. So those angles are congruent to each other. Do we have enough information to prove our triangles congruent to each other? Yes. 4. So triangle AYX is going to be congruent to triangle CZX by angle, 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 side. The only other way you can say angle, 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 side is to say angle, side, angle, but that side would have to be between the two angles, and it's not without stating something about 3 and 4. Question. We're looking at proving two triangles congruent. So we can either use hypotenuse leg. Does that look like an option in this one? No, probably not. Side, 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 angle, side, or angle, 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 side. So we got to think of those 4. Now, if it gave us parts and it said prove that some angle E is congruent to angle D or something like that, then you would first have to prove the triangle's congruent, and then CPCTC, corresponding parts of congruent triangles are congruent. Okay, so we need to mark the given information. They tell us that angle A is congruent to angle C, and AE is congruent to DC. We want to prove triangle ABE is congruent to triangle CBD. So the 2 outside triangles. What are we going to use? Sometimes I think of it as like name that tune. I can do this by combining those right there. I can do this proof in 2 steps. Side angle side. So if we do side angle side, we look at it and we have side angle side. What side do we need to prove congruent? AB and CD. Now I know that AB is congruent to say to CD. Why? Very good. The converse of what you told me before, right? So sides opposite congruent angles are congruent. Now keep in mind that has to be within the same triangle. Sometimes people think that if they're in different triangles, you can make that statement, but you can't. It has to be within the same triangle. Here's why different triangles does not work. And that's all in the same triangle, right? The big triangle. It's all on the big triangle. This is why different triangles do not work, because I'm just going to give you a basic one that you are used to. Would you agree that these 2 angles are congruent to each other? Yes, they are. But are the sides opposite of them equal to each other? No, they are not. Similar triangles have congruent angles, but the sides are proportional to each other. So if I were not to make that one big triangle and I was just looking right here at that figure without this baseline right here, seeing a big triangle, I can't just say, well, I got these 2 triangles here, so those 2 sides got to be equal because they're opposite equal angles. Can't say that. Okay. All right. So you were able to tell me this was true because they are opposite of those equal angles. And therefore, triangle ABE is congruent to triangle CBD by side angle side. If you really wanted to get technical, like I said, I doubt if you write these proofs in college, but you could say the congruency postulate. There is a difference between a congruency postulate and the similarity postulate, if you really wanted to get into depth with proofs, which I took a whole semester of it. And that's all we did was write proofs. Yeah. One proof was like a page long or more. And then it was, yeah. But I really don't foresee, you guys having to do that. And we didn't have a book, it was just all these. I swear I hit, there we go.
20, I know how to do it, and I got the answer, but I don't know if it's the right answer. I got -1/2 plus 2y.
What did you say? Emma?
Negative 1/2 of 2i.
Close. Don't erase a lot of things. Anybody else have something different? 8 minus 2i?
Me too, that's where I have. But then I clicked one down.
Okay, what, number 20. It might just be reducing. You had 8. What did you have again?
8 minus 2i over 5.
Okay. You had that?
Yes.
That's what you had?
Is this true?
They don't like i's in the denominator, right? So what they're going to do is they're going to multiply numerator and denominator by I. See that thickness? I don't know if I like that. You are so close. You get down to this point and you're close. Are we okay to that point of 8 minus 2i over 4i?
Yes.
I want to stop measuring this stuff. Okay. Anybody else except for her? You are okay to that point?
Yes.
Marley, not Marley. Kayla, you're okay to that point? Okay, so we multiply by I. Use the distributive property, which gives you 8i minus 2i squared over 4i squared. What is I squared the same thing as? -1. So I'm going to show a little bit of work. I'm going to write it down just so some of us can see it. Okay, so that simplifies into 8i plus 2 over -4. All you have wrong is the sign. Because you look at it, the first term is going to be 8i over -4, and the second one is going to be 2 over -4, which gives you -2i minus 1/2, or -1/2 minus 2i, and I believe you told me plus 2i. So it's just that sign, and if you had the minus 2i up above, then that black was correct. It was just what they consider rationalizing the denominator with imaginary numbers. So I think you just had that sign incorrect. You stopped with the black. That's okay. That was a good starting point for me to go from there. Yeah. We know the highest power of I should be what? 1.
And then 21. You put those in two different stop shapes.
Yes. So you start off with what? 1 over. Oh,
okay.
Isaiah.
I missed that.
No, yours is not correct.
Oh.
I did something wrong. I think I looked at, I don't think, wait. It might be right. It might be right now that I think about it. For some odd reason, that y to the first was throwing me off. You took the first one times y to the fourth? Okay, never mind. I think you're good. But please double check it. Don't space out when I do this, just in case. Okay? So we have 1 over y to the 5th. And that denominator, y to the 5th is already positive, so I'm going to leave that in the numerator. And x to the -4th gets dropped down. Now I can do that because I can write that as one fraction in the denominator because they're being multiplied together. There's not a plus or a minus. So what's your common denominator? The common denominator is x to the 3rd, y to the 5th. So what do you have to do to the first fraction? Take it times y to the 4th. What do you have to do to the second fraction? Take it times x to the 3rd. So you have a common denominator, which is x cubed y to the 5th. So you add the numerators, y to the 4th plus x cubed. Now what does this line right there mean? Divide. So you're going to take that top fraction and divide by the bottom fraction. But how do you divide fractions? Keep, change, flip. So I want to move this up by flipping it. So I'm going to get x to the 4th over y to the 5th. Now what happens? Well, 3 of these cancel, and I'm gonna, sorry, but for those that are gone, well, if they've watched the video, they will see it. But 3 of those cancel with 3 here. So that leaves you with 1 x in the numerator. So you are multiplying these two together. So if you take this x that you're left with over here and you use the distributive property, which I don't care, you could probably write it, I don't know. What does it have that multiplied out in the back of the book? So they show their answer as x to the 1st, y to the 4th, plus x to the 4th over y to the 10th. All right. Good. So the construction, it has all the same sides and all the same angles if you look for a polygon to be regular. Use a compass to construct a circle. You could do that, right? There's your circle. Does that look like the center? Okay. The next thing they say, choose a point on the circle and call it A without changing the compass setting. So what's your compass at? What is the length of your compass right now? The same thing as the radius of your circle, because we went like this, right? And made the circle. So without changing that, if you could keep that distance, let me see if I can, I'll try to do this, but I can't touch the board. I think I'm going to run into troubles trying to touch it. Yeah, we'll see how this works. I needed it to be a little bit bigger. Okay, without changing that compass setting, start at A and draw a series of arcs on the circle. Okay, so I just need to pick a point A. I don't care. They pick theirs right up here. And you're just going to mark arcs as you go around. Then connect the adjacent points. So you put the point of your compass here, and you strike an arc. Oops. You put the point of your compass there, strike an arc. Put the point of your compass, which now it's blocking, strike an arc. Okay, that worked, I guess. Right. Strike an arc, point. Oh, guess what? Somehow I didn't do that right. We closer. Okay, we're going to call it close. I tried with the utensils I got for up here. If I did this at my desk, I could get there. Then they ask you to connect these, and when you connect them, you get a regular hexagon. It's not too bad of a construction. Well, now that makes that side look really bad. Trying to fix the top, distorted it. But anyway, that's all you got to do is keep that distance the same and mark it all the way. Why?
Because the radius is around
6.28 times.
Well, that's why you had too much.
Mm-hmm. Yep. Actually, I should have a little bit. Yeah, I did have too much because I did go over. But it should have been short is what it should have been. It should have been short because it goes around there 6.28 times, and I didn't quite make it around 6 times. 1, 2, 3, 4, 5. I didn't quite make it around 6 because mine was longer. It should have been short 0.28. Wait, up. Are we good?
28.
Uh-huh. You what?
I'm not good at these.
Isaiah, would you like to come up and explain it?
Sure.
Do you want me to write? You can write. We'll let you. Isaiah had it down, but he came in during study hall just to double check. So I'm going to see now how well he can explain it.
All right, so formula for surface area of sphere is 4 pi r squared. So your surface area of the small one is pi centimeters squared, so it would be that divided by 4. So
Put your formula down, 4 pi r squared. Now that's equal to what? What's the surface area? Pi. So we set that equal to pi. So if you set that equal to pi, how are you going to solve? And 4. So that's what Isaiah did. He divided by 4 pi. He did a lot of this mentally. So having him write it down right now
really
is good because I wanted him to write it down. Because you started talking and he could just look like, okay, what did he just say? I don't get it. Okay, so here, you tell me and then I'll do it. Okay, I'll show what you think because your thought was correct. He just didn't have much written down and I was following along. Okay, so what? You can sit next. Oh, would you like to just sit this? Because then you're by the microphone, which is right there. Okay? All right.
So
So he solved. And he said, actually, he jumped ahead and he said the radius is equal to what? Radius squared is equal to 1/4. Okay, so there's a starting spot.
and then the bigger circle, the surface area is 36 pi centimeters. So you take that divided by 4 pi. And then you get 9. And then you take the square root of that to find the radius, which is 3.
Okay, are we with Isaiah so far? Okay, we had to do that because they just want to know what is the difference in the volume of the two spheres. Okay, but what is the formula for volume of a sphere?
4/3 pi.
So we had to know what that volume was. So the volume of the small sphere, go ahead, Isaiah.
And 4/3 pi times 1/2 cubed, which is 1.
That's not the way you did it, but yeah, okay.
Then you get 0.6.
A lot of people, I swear it was because back in 5th grade when you guys learned fractions or something, did you guys have Mrs. Kravenstein? You were not told, I don't think you were ever told to reduce right here.
No.
You were told to multiply numerator, multiply denominator, and then reduce. Because otherwise,
I always do.
Yeah.
everybody always does.
You do it.
Yeah.
It was back when you guys first learned it, and I know there's probably a reason for it. Probably because when you
I mean,
are,
back then it was just a lot simpler. So,
yeah,
like all we had to
Yeah.
do was multiply the fractions. There wasn't a big problem with it. So.
but I don't know. I
But
always,
you can get a different answer sometimes.
well, this would be, as Isaiah told me when he came up and he was talking to me, 4/24. And no offense if Kaylee, you rewatch this, I have no offense to your mom for showing you that. I'm just saying that I know it was taught and I know there's a reason, just like we had our math PLC last Monday. And this one teacher there just, oh, you say cross multiply and divide and he freaks out. And I know why he does, for the same reason kids do. The kids do this. Here you're multiplying these and his students want to cross multiply and divide. So they want to take multiplying fractions and they say cross multiply and divide. And it's when you have a proportion that you cross multiply and divide. So he said, my students are not allowed to ever say cross multiply and divide in my class. Now here, I just find it easier to reduce because I like smaller numbers. I don't like to have to try to divide big numbers and find out what they are. So no offense, Mrs. Grabenstein, whatever. But that reduces, 4 goes into 24 6 times then and you get 1/6 pi. And then,
Yeah, that's the volume I'm small for.
just like this one, I do different too. So continue.
Right. So then, yeah, you gotta multiply 4/3 times 9. Or yeah,
But 3
27,
goes
not
into
9,
27 9 times, and 9 times 4 is
36.
36 pi.
Actually, is how I did that. So,
That is the way you did that one. But I would do it differently because I would look at it this way. I would look at it as 4/3, and since that's a multiple of 3, that's the way I thought of it. But yes, you are correct with that. Okay, but what do they want? Do they have we found
difference.
the difference? So then what do we have to do?
36
So we're going to have to take
36 times 6.
36 pi. Oh, you're going to a lot of work too. And we're going to subtract 1/6 pi. What's 36 minus? Oh, I don't know if you had it right. You did not have it right. I think you put 1/6 down. What happens when you take a 6th away from 36? You get, did you have 5/6? I don't know if you did. Go back and look. So you get 35 and 5/6 pi. If you want, that is a, did you have 1/6? I did not catch that when you were here. See, I knew that there was something that was wrong. It just takes me a while. And I thought you had 5/6 when I looked at it. I was like, yeah, it's okay. I've done that before too. So 36 minus 1/6. You could either take 36 times 6. What is that? Is that 196? No. 18, 19, 20, 21, 216? No.
Centimeters cubed.
Yeah, cubic centimeters. You got to subtract though from it. So it'd be what? That might be it. $215.6 pi cubic centimeters.